start recording. Okay, so now we are about to start garbage collection. Close all tabs. So what is garbage collection? I think we require only one class, A, and right. So garbage collector works on which memory in Java?
Heap.
Nice. Okay, how many memories are there in Java?
3. Heap memory, stack memory, and non-heap memory.
Cool. And garbage collector works on
Heap memory.
only heap memory, right? It don't work on stack, or non-heap also it don't work. Cool. So
Hmm.
which variables are stored in heap memory?
Instance.
Nice. Which variables are stored in local memory? Oh, stack memory.
Local.
And which variables are stored in non-heap memory?
Static.
Nice. All right. So we are working with the heap, right, over here. Garbage collector works on
Hmm.
heap, right? So which variable should I write?
Instance variable.
Okay, cool. String name, right? So let's take an int or employee ID, emp ID, and let's randomly take 101. Cool. So and okay. So if which class is the parent class of all Java objects?
Object less.
So whether I write extends object or not, it is same, right?
Yes.
Cool. So now if we know this, and I mentioned that we are going to, in our course, we are going to see all these methods, right? Right now I am using Java 17. Okay. If we go inside IntelliJ and in my settings, not IntelliJ settings, if we go inside module setting, okay, if we go inside our module settings, so you can see I'm using Java 17, right? So what will happen, I mean in 17 the one of the methods over here you will see that it is obsolete, finalize. It is obsolete from Java 9, right? Deprecated. Cool. But we will still see what is this and how it runs and what it matters, right? So let's take an example in garbage collector, how garbage collector works, right? So how we run the code, a equals to new a, right? This is how it works, right? And we don't need to write anything over here right now. So if I create an object a equals to new a, and I try to run it, then there is nothing, we cannot make sure that when it's sent, because the machine has closed, right? There is no machine is up right now till now, right? So we cannot make sure that our object is destroyed. I mean our object is destroyed or JVM is closed. But if I say that thread.sleep in 4 seconds, okay, so okay, thread.sleep is just for make sure that our system don't close for 4 seconds, right now but we are using it. Okay, so if I run this, even for 4 seconds nothing is happening, right? And we cannot make sure that whether it's deleted or not. So the very first thing is, when we know that this object is created on heap, right? And for heap what will happen, it will go inside this class and try to check all the instance variable, because only instance variable are persisted in heap memory, right? Cool. So now we know that okay, this object is having data only on heap memory, because local variable will have in the stack memory, and local variables are created during the method execution, and static variables are provided memory during the class load time. So object deals with only instance variables because it works in instance space. So now when will a garbage collector knows that it can delete an object? When no
The function is done. When the method is done.
no, that's when we know that we can destroy the stack of a method. For an object, we know that if no variable is pointing to that particular object, right? Right now no variable is pointing to a, right? Because a is pointing to null. Over here a is pointing to the object in heap, but over here now no one is pointing to a, right? Because I have made a point to null, right? So now it is eligible for garbage collection. And when the garbage collector collects the garbage, then what it do, it execute the finalize method. Garbage collector called finalized, okay, or simple a finalize method. Cool. Executed. See, right? So what usually happens when an object is destroyed, finalize method is called. Cool. So that means if we run this method again, then finalize keyword will be called, right? So let's see. We are waiting for 1, 2, 3 and 4 seconds and nothing happened, right? Why nothing happened? Because garbage collector don't work every time. It's not up every time. It will work based on its condition, and the condition is provided by the JVM implementer, right? I think I'm using the Corinto, which is provided by AWS. Okay, no, I'm not using Corinto. Okay, I mean there are multiple. Oracle provides the Java implementation, AWS provides the Java implementation. So whichever Java implementation you are using, they are responsible to provide you the logic of the garbage collector and when it will run. But we can do one thing. We can request garbage collector to start working. Cool. But when we call system.gc, we are calling garbage collector and we are requesting garbage collector to start its work. But the thing to note is, over here garbage gc method of system class, it's run the garbage collector in the JVM, right? But the next line you will see that calling the garbage method suggests that JVM machine expend the effort toward recycling unusable objects. Which are unusable objects? To which no one is pointing, right? If no reference variable is pointing to an object, so we cannot access the object, so we cannot call any methods or we cannot access any variables of it, right? So it can be deleted. Unused object is the object where no one is pointing towards that particular object in the heap. So calling the GC method suggests JVM to expand its effort towards recycling the unused object, right? In order to make memory they are currently occupied available for reuse. But the thing is, it is not making it compulsory for the garbage collector to start working. We can just request it, right? We can just suggesting that. Over here, if you read more, then when control returns from the method call, Java virtual machine has made a best effort to reclaim the space of unused. There is no guarantee that this effort will recycle any particular number of unused object or reclaim any particular amount of space or complete at any particular time, if at all, before method runs over. There is no guarantee that this effort will determine change in reachability of any number of objects or particular number of reference which will be cared on in queue. Cool. So it means that you cannot make sure, I mean you can just request the GC, right? You can just request the GC to start it working. It does not provide guarantee that it will start working, right? To start collecting garbage. Cool. So now if I run it again, finalize is executed, right? Because I asked GC to start its working. Because we have only one, our code is way too less, right? We have only one object that we are pointing and then one object we have cleaned. So that's why it's way too fast to execute this method. If we don't do this, and then if we try to execute the code, it will be way too early to garbage collect to start its work, right? So that's why we call system.gc. Both things that we have done till now today, both are interview questions. Cool. There is one final thing that one needs to know. Now it's not important because this finalize keyword is obsolete. The one thing to know, and that you can rote learn, right? That if there is some exception arise, like if I divide int a equals to and 10 divided by 0, so it will give an arithmetic exception, right? So, and if I try to print anything, line after exception, line after exception, if I try to run it, you will find that nothing will happen. If I try to do this in a normal method, then exception will be printed. For example, if I do it inside the runner only, if I write this line, right, now I try to execute, then it will provide the error in line number 9. Variable a is already, okay, where variable a, okay, cool, let's make it b, and then run it again. See, exception, right? Divided by 0, arithmetic exception. And same line we have used over here, but there is no error. And the line after the exception is also not printed, right? Only this thing is printed. And just to make sure that I am not just doing anything, let's add 1 1 just to make sure that it is reflecting the latest code, right? 1 1 minus 1 1 is there. Let's remove it and run it again. Then you will find that minus 1 1 is removed. So okay, so the changes is happening, but the exception is not handling, right? Because what's happened, we'll see in the later on classes in exception handling, that we provide a throwable object to the JVM, right? But in the finalize keyword, because we are deleting the particular object and we are at the final phase of deleting the object, so if any exception arises in the finalize method, then we don't, the JVM don't take it, or it won't entertain that particular exception. Cool. So we should not write any code in the finalize keyword that might throw an error. And this entire thing is now not that much required, because it's already obsolete, so no one is going to ask you the question. The only important question left out of this garbage collection is System.gc, and when an object is eligible for garbage collection, when no one is pointing to that particular object. Cool. If I'll comment out this, then A is pointing to A, right? Object of A. Now there will be no garbage collection. See, 1 2 3 and 4, and it ended. No garbage collection, right? But if I make it null and no one is pointing to A, then see, finalize keyword executed, right? Okay, so this is.
So in order to run the garbage collection, we have to give A is equals to like a null. We have to use that null.
It's not mandatory. There might be a chance that you have passed a particular variable somewhere, right? And that particular method is deleted. So now that variable does not exist anymore, which was holding the value of this variable A, right? So there might be a chance, right? And also this memory is in, for example, if the main method ends, then the entire stack is dead, right? Because this is the main part which runs. Let's say that we are doing this in over here. We are doing something in public void m2. Cool. And over here also I am creating this object. Okay, so what will happen? And if we are creating an object in heap over here, right? And the reference variable is in the stack memory, right? Reference variable A is in the stack memory, and this object A is in the heap memory, right? As soon as this method ends, there is no A variable, right? Because stack memory is deleted, right? As soon as the method ends. So if there is no variable A to hold anything, and this memory is in heap, and no one is pointing towards this A, now this will be eligible for garbage collection, right? So this is how it usually happens. It's not like we have to point null, because the variable gets deleted as soon as the method ends. Right now we are doing it in the main method. That's a different story, but no one is going to do this in main method, right? It will be in some instance method. When instance method ends its execution, then the reference variable won't exist anymore. So if it won't exist anymore, then we don't have to change its reference from that particular object to null, right? Okay, if you have any doubt, you can ask again.